Okay, so the third method that we are going to learn in order to solve a system of equations. Remember, a system simply means that there's two equations and you're looking for the solution that fits for both of them. The elimination method is a method for solving systems of equations by either adding or subtracting the two equations. I'll show you what that means and what that looks like, to eliminate one of the variables, at least in the first step. Okay, so step one, make sure the equations are lined up. What that means is standard form, and we've done standard form. AX plus BY equals C. So you have to make sure they're in standard form. If they're not in standard form, then you have to put them in standard form. Okay. Once they're in standard form, I'm going to come over here and make this note. Your X numbers or the Y numbers, the X's or the Y's, and I'll show you what this looks like, must be exactly the same or exactly opposite. So 5 and 5 would be the same. Opposites would be something like 10 and negative 10. Same number, just one's positive and one's negative. Those are opposites. Again, I'll show you what this looks like. Just make sure that you understand either your X numbers or your Y numbers have to be exactly the same or exactly opposite. If you have that, then you're going to decide whether to add or subtract the two equations. And when you do that, you need to choose the operation that would eliminate the variable with the common coefficient, the number in front, the X's or the Y's. Once you do that, after you add or subtract the two equations, you're going to eliminate one of the variables. You're going to solve for whatever's left, whatever variable's left. When you get that, then you will substitute your answer into the either original equation and solve for the other variable. That probably does not make any sense. So let's see a problem and I'll show you what I'm talking about. Let's skip number one. We're going to come back to number one, but let's look at number two. You have 1x plus 4y equals 13, and you also have 1x minus 1y equals 3. These coefficients of x are both 1, positive 1 and positive 1. They are exactly the same. So what you're looking for are numbers that are in front of the x's that are exactly the same or exactly opposites. Or in front of the y's, it doesn't matter. The number in front of this y is a 4. The number in front of this y is a negative 1. These are not the same, and they're not opposites either. Opposite of positive 4 would be negative 4. So they're neither. So the y's don't help me, but the ones are a 1x. The x's are a 1x and a 1x. So if I took these two equations and I subtracted like terms, look what you get. X take away x is 0. The x's go away, or they are eliminated. Okay, now I need to do the y's. You got to be very careful when you're subtracting. It's 4y take away negative 1y. So it's 4y take away negative 1y. 4y take away negative 1y turns into 5y. And now I need to do the constants as well. You got to do it across the board. So when we decide to subtract to eliminate the x's, We got to subtract here, we have to subtract here, and we also have to subtract here. And 13 take away 3 is 10. And if you'll see what's happened is my x numbers have gone away, and I'm left with this one-step equation that I can solve really easily. I just need to divide both sides by 5, and that gives me y equals 2. So don't stop there. I have found my y number to be 2. This next step you already know how to do. Go back and choose one of your equations. It doesn't matter which one. Pick the easier one and substitute the 2 in for y. I'm going to use the second one. So the second equation says x minus y equals 3. But I'm going to plug a 2 in for y here. So x minus 2 equals 3, and I can solve that really easy. I just need to add 2 to both sides, and that gives me x equals 5. There's my solution. Okay. Let's take a look at another one. Number 3. Actually, let's look at 4. The x numbers are 4 and negative 2. They are not the same, and they are not opposites. When I say opposites, I mean exact opposites. The opposite of 4 would be negative 4. These are neither. So the x numbers do not help me. But these y numbers, positive 2 and positive 2. So since these numbers are exactly the same, if I subtracted these, and this is what you have to figure out, do I need to add these equations or subtract them? Well, if these numbers are the same, if I wanted to eliminate them, I would subtract them because 2 minus 2 is 0. So I need to subtract the x's, subtract here, these will go away, and subtract here. You got to be careful when you're subtracting. 4 take away negative 2. 4 take away negative 2 is 6x. 2 take away 2 is 0, that goes away. 6 take away 18. 6 take away 18 is negative 12. And you're left with the one-step equation. You simply divide by 6, and you get x equals negative 2. Now you have found the x number. Same process. Pick one of the equations. It does not matter which one. And substitute in negative 2 for x. I'll pick the first one. 4x plus 2y equals 6. I'm going to substitute in negative 2 for x. So this becomes 4 times negative 2 plus 2y equals 6. And now I can solve this equation for y. Go ahead and multiply these together. You get negative 8 plus 2y equals 6. And now it's a two-step equation. Get y by itself. Plus 8 here. Go across the equal sign, plus 8. You get 2y equals 14. And when you divide both sides by 2, you get y equals 7. Okay. Now, those two problems, the coefficients were exactly the same. So if they are the same, then you subtract. Same, subtract, two s's. If the coefficients are the same, then you're going to subtract. What if the coefficients are opposites? Let's look at number 5. I have 4 and negative 4. These are exactly opposites, and that's what I'm looking for. The y numbers are 9 and 7. That does not help me, but these are exactly opposites. So in order to get these to cancel out, I wouldn't subtract. In this case, I would add. 4 plus negative 4 is 0. If you add opposites, you get 0. 9 plus 7 is 16y, and 5 plus 11 is 16. So now you can see I can solve for y really easy, just dividing both sides by 16, and you get y equals 1. I found my y number. To find my x number, go back to either of the original equations and plug a 1 in for y. So I'm going to choose the first one because it doesn't have any negatives in it. That's the only reason I picked it. I could have chose the second one. So I'm going to take this number and I'm going to plug it in for y. So this becomes 4x plus 9 times 1 equals 5. It's just a process. 9 times 1 is 9. Solving for x, it's a two-step equation. Take away 9 from both sides, and you're left with 4x equals negative 4. And then when you divide both sides by positive 4, you get x equals negative 1. Okay. So, what if they are not lined up? Actually, hang on a second. Let's make a note on this one. If they are opposites, if your numbers are opposites, then you add the two equations. These were opposites. So if they are the same, you subtract. If they are opposite, you add. What if they are not lined up? So look at number 1. Now we'll go back to 1. This is one that if I saw, I would probably either graph it real quick because they're both in slope-intercept form, or I might even use substitution where I would plug this in for here. I would plug 3x plus 4 in for y here and use substitution. So if you see one like this, I probably would not use elimination. But if we want to use elimination, then let's show you what that looks like. We need to line them up. And remember, they need to be in standard form. The x's and y's need to be on one side, and your constant needs to be on the other side. So your constant is by itself. So in the first problem, your constant is 4. If I wanted to get 4 by itself, I would simply minus 3x. So if I minus 3x and minus 3x, then that first equation becomes negative 3x plus y equals 4. If I minus 3x here, that goes away. And if I put the negative 3x plus that y on that side, that's what I get. For this one, the constant's negative 2, so I would take away x from both sides, and I would be left with negative x. Getting the constant by itself, that's what we want to do in standard form. Move the x to the other side by subtracting x. So you're left with negative x and then plus the y. And now you can see that you can use elimination. These are the same, 1y and 1y. They are the same, so we subtract. Negative 3 minus negative 1. Think about it. It's negative 3 minus negative 1. Well, that turns into negative 2. X equals, and then 4, take away negative 2 is 6. Divide both sides by negative 2 and you get x equals negative 3. So I've got my x number. To find my y number, plug this number in for x. I'm going to plug it into the second one. The second equation says y equals x minus 2. I'm going to plug a negative 3 in for x. Negative 3 minus 2 is negative 5. So there's a solution on it. So most of the time, if you're using elimination, they'll be lined up for you. Like question 2 we did, like question 4, like question 5. Look at number 6. We're not going to work it, but would you add or subtract these? Well, the 10 and negative 2, they're not the same and they're not opposites. But this negative 3 and positive 3 are opposites. So if they're opposites, we would add these two equations. Okay, that is lesson 41.